Hey, Miss Marion here. We are doing Unit 5, Lessons 17 and 18. So turn back to page 195. Let's read the I can statements for Lesson 17. I can explain in my own words by changing the height by a scale factor changes the volume by the same scale factor. And I can create a graph that have the relationships between volume and height for all cylinders or cones with a fixed radius. So again, we're also going to read lesson 18. I can explain in my own words by changing the height of a scale factor changes the volume by the same scale factor, and also we can create the relationship between volume and height for cylinders or cones with a fixed radius. So these two kind of come together. It's on page 195 and 196. Go ahead and write yourself a sentence on about these I can statements. Also give yourself a number. So 1, I don't remember. 2, I kind of remember it. 3, I do remember. And 4, I can teach it to my friend. Let's go ahead and turn to page 141. It says, here's a graph of the amount of gas burned during a trip by a tractor trailer truck, that's a semi-truck, as it drives at a constant speed down the highway. So we're going to go ahead and answer these questions. So at the end of the trip, how far did the truck drive? How much gas did it use? If a truck traveled half this distance at the same rate, how much gas would it use? If the truck traveled double the distance at the same rate, how much would it use? And then let's complete the sentence. Blank is a function of blank. So you're going to need to go ahead and pause this and answer those questions. So pause, answer those questions, and then come back to me. All right, let's go ahead and look at number 1. At the end of the trip, how far did the truck drive? So that's kind of this point way over here. Let's put a different color on there. Let's put red. Okay. And so this point is 240, 30. And if we label it as 240 miles and 30 gallons. So what does that actually mean? At the end of the trip, how far did the truck drive? It is 240 miles, and it used 30 gallons of gas. So let's think about it. If the truck traveled half the distance at the same rate, how much gas would it use? And so if we went half the distance, well, let's think about that. If we went half the distance, that means we're going to do half the gallons. So what would that be? Oh, that's going to be 30 and then divided by 2, which is 15 gallons of gas. Okay. What if it doubled? Okay, so doubling, we have the 30 and we're going to double it. That means we're going to do 60 gallons of gas. So let's kind of put it all together. That means the gas burned is a function of the miles traveled. So let's go ahead and let's turn to page 141. Let's look at activity number 2. There are many rectangular prisms with one edge of length 5 units and another edge of length 3. Let S represent the length of the third edge and V represents the volume of the prisms. So first of all, we're going to go ahead and write an equation that represents the relationship, and then we're going to go ahead and we're going to graph it. First of all, let's just go ahead and write the equation first, and then let's go ahead and graph it after. So just answer number 1 and then come back to me. So let's remember the volume of a rectangular prism that's kind of like a cube, but it's rectangles, right? It's length times width times height. So let's put in the information that we have. We have a length of 5, and we also have a length of 3. So we're going to have our volume is 3, or sorry, let's do the first one first. Let's do 5 times 3, and then we don't have that last one, which is the height. So our equation for here is 15h. Let's go ahead and now let's go and make a graph. So we're going to take this v equals 15h. You're going to go ahead and do a graph. So you're going to label your x-axis, your y-axis. You're going to figure out what is your independent variable, your dependent variable, and then go ahead and graph everything. So go ahead and pause right now. Go ahead and graph that. And then come back to me, please. All right, this is the graph that you should have. Notice how I went ahead and I made a table here for this graph that goes along with it. Our side length is our independent and our volume is our dependent, because the volume will depend on whatever side length that we'll go ahead and have. So again, I did make a table, and then we did have our side length, and then we have our volume, and then our numbers that go along with it. So let's look at number 3. Okay, so we have this rectangular prism. It has a unit of length 5, another length of 3. We did our equation, right? Our V equals 15H. Now it says, what happens to the volume if you double the edge of side S? And where do you see this on the graph, and where do you see it algebraically? So go ahead and think about that. What happens if I double it? What would happen with that volume? So go ahead and answer that question and then come back to me. So let's kind of think about this. So our original equation we have as our volume equals our volume equals 15 times H. And what they're thinking about is if I take that side length and I actually double it, so it's pretty much like 2H. So if I have, really what I'm going to have is 15 times 2H, is because I'm doubling that edge. Well, 15 times 2 is 30. So really, my equation is going to be V equals 30H. So notice how if I double the side length, it's going to be doubling kind of what's going on as far as the volume itself. So on page 143, we have activity number 3. There are many cylinders with radius 5. Let H represent the height and V represent the volume of these cylinders. Write an equation that represents the relationship between V and H. Use 3.14 as an approximation for pi, and then eventually we're going to go ahead and graph it. First of all, let's go ahead and figure out the equation, the volume equation first, before we go ahead and graph. So go ahead and pause, answer just the equation part, and then come back to me. All right, so remember that the volume for a cylinder is pi times radius squared times height. And then what information is given to us? We have the radius of 5 units. Let's put that in. So we're going to have pi, we're going to have 5 squared, and then we're going to have height. Let's go ahead and kind of look at this a little bit further. We have pi. What is 5 squared, or a radius squared? That's 25. And then H. And then it told us to do 3.14 for pi. So let's take 20 times 3.14, and we are actually going to get our volume 78.5, and then H. So this is our equation for number 1. So we're going to have the V equals 78.5 H. That's our equation. Now you need to go ahead and graph it. So the easiest way to go ahead and do is to go ahead and make a table with this equation. Figure out your independent variable and your dependent variable. Go ahead and graph that and then come back to me. All right, so this is our graph that we ended up having. So notice how I did a table with my equation. Again, the equation was V equals 78.5 H. So I put some points in there, and I went ahead and made the graph itself. Notice how my independent variable is the height of the cylinder. My volume is the dependent variable, so the volume will depend on the height of the cylinder, and it will actually go ahead and change that, and it will show it through this line here. So let's look at number 3. It says, what happens to the volume if you half the height? Where can you see this in the graph, and then how can you see it algebraically? So go ahead and pause and answer that question, and then come back to me. So just kind of as we did it before, so remember, if I take that height and I go ahead and I have it, so I'm going to have 78.5, and I'm going to divide it by 2, so 78.5 divided by 2 equals the 39.25. So our equation would be V equals 39.25 H instead of the V equals 78.5 H. Let's go ahead and turn to page 144, and we're going to look at this question. There's a graph with a relationship between the height and the volume of some cones that all have the same radius. What do the coordinates of the labeled point represent? What is the volume of the cone with height 5? What is the volume of the cone with height 30? Use and label a point to find the radius of these cones. Use 3.14 as approximation of pi. And eventually we're going to write an equation for this graph itself. So go ahead and answer those questions. So you need to pause, go ahead and answer those questions, and then come back to me. So let's go ahead and let's kind of go through this itself. So we're looking at this point itself, right? And so it's saying that the height of the cone is 10. And then when the height is of the cone is 10, the volume is going to be 2,555. That is number 1. Number 2, what is the volume of the cone with height of 5? So let's go ahead and kind of go through that. If we look at the graph itself, it's going to be probably around 1,000 something. So the actual amount would be about 1,177. Well, let's write that a little bit nicer. So 1,177.5, and then cubic units. So it's going to be units cubed. So how do we know that this is the actual amount itself? So notice how we had 10 was our height, and we went to 5 as our height. So we took that 10 and we divided it by 2. So we went 10 divided by 2, and we got our 5. That means we're going to take the 2,355 and we're going to divide it by 2 to get the 1,177.5 units cubed. So what about when the volume of the cone, when the height is 30? So again, we started with 10. And then what did we do to go ahead and get 30? We took the 10 and we multiplied by 3 to get 30. So what would that actually leave as far as the final amount itself? We're going to take the 2,355 and we're going to multiply it by 3. So let's do that. And we're going to get 7,065 units cubed. So this is kind of, if we have the height, then we're going to have the volume. If we're going to multiply it by 3 for the height, we're going to multiply by 3 for the volume. So on number 3, it says, use the labeled point to find the radius of these cones. Use 3.14 as the approximation of pi. So it's kind of like what we did in lesson 16. We took the volume equation itself. So our volume equation is volume equals 1/3 times pi times radius squared times height, right? And then we know what, and we're going to use this point over here. So our volume is 2,355. Still 1/3 with 3.14 times. We're looking for the radius squared, and then we have also our h. On the right-hand side, let's multiply all of these numbers together. So we're going to say 1/3 times 3.14 times 10. And we get about 10.47. We're going to round it to 2 decimal places. So we're going to say 10.47 radius squared, and then 2,355. How do we get the radius squared by itself? We are going to go ahead and we are going to divide by the 10.47 on both sides. So we take 2,355 divided by 10.37, or sorry, 47. And we are going to get for our r squared, sorry, let's write it the other way around. We're going to get 224.9 equals our r squared. So let's kind of round that up just a tiny bit to kind of help us out. So we're going to say 225 equals r squared. The reason why is one number multiplied by itself makes 225. Oh, that's 15. So our radius is going to end up being 15. All right, so let's go ahead and let's put all of this together to go ahead and write the equation for number 4. So we have our v equals 1/3 times pi. Our radius is 15 squared, and then we have our height. because we're writing the equation. The height is what kind of changed in the graph itself, but we're going to go ahead and multiply all these together. So let's take 15 squared times 1/3, and we get 75. So then our final equation is going to be V equals 75 pi and then H. This is our equation for number 4. So notice how if we have an equation for a volume, if we half the information, then we're going to half the volume. If we're going to double the height, then we're going to double the volume. If we're going to double, so it kind of corresponds with each other. And so this is when we're dealing with the height itself. So let's go ahead and let's turn to page 150 and lesson 18. And in this lesson, it says, Claire sketched a rectangular prism with a height of 11 and a square base and labels the edges of the base S. She asks Han what he thinks will happen with the volume of the rectangular prism if she triples S. Han says the volume will be 9 times bigger. Is he right? Explain how you know and or show your answer itself. Go ahead and pause, answer that question, and then come back to me. So let's figure out if Han was correct or not, if it's going to be 9 times bigger. So first of all, let's think about the equation for Claire's rectangular prism. So it has a height of 11, and it has a square base, and the sides are labeled as S. So let's go ahead. I'm going to just, all right, so I went ahead and I sketched my rectangular prism. I have a height of 11, and both of these are S's, not 5's. Okay, so if we were trying to find the volume just of this, we're going to have volume as S times 11. So that's going to be 11 and then S squared. S times S is S squared. So this is our original. And then they talk about what happens if we take the rectangular prism and we triple the S. So let's go ahead and so instead of having S, we're going to say it's 3S. So let's go ahead and let's put that all together. So we still have our original, let's put it in blue. The original was 11S squared. We changed everything. So we still have 11. S is now 3S and then squared. So this is what it's saying. It's going to be 11 times 3S times 3S. 3 times 3 is 9. S times S is S squared, and we still have this 11. So notice, let's look at these. So here I have 11S squared. Here I have 11 times 9S squared. So is Han actually correct? He is. Notice how the extra piece in here is that we have it as multiplied by 9. It makes it 9 times bigger. So eventually the final equation itself will be 99S to the second. But we do actually notice how it will be 9 times as big. So on page 150 and 151, we have there are many cones of a height of 7. Let R represent the radius and V represent the volume of these cones. Write an equation that expresses the relationship between V and R. Use 3.14 as pi. So you're going to have a decimal when you go ahead and write this volume equation. So go ahead and figure that out. Pause and figure that out and come back to me. So let's first of all write down the equation for a cone. Our equation is V equals 1/3 times pi times radius squared times height, right? Our height is 7, so we're given that information and we want to use 3.14. So we have 1/3 times 3.14 times 7, and then we have R squared still left over. So let's grab our calculators. Let's do 1/3 times 3.14 times 7. What do we get? And we're going to round it to the nearest hundredths place. So what we get in our calculator is 7.326 repeating. And we want to write it to round it to 2 decimal places. So I have the 2. I'm going to look at the 6. Is 6 or 5 or above? Yes. Give the original a shove. So we're going to have 7.33 as our, and then we're going to have it as our second decimal point, and then r squared. So this is our equation for this situation itself. And then number 2, it says predict what happens to the volume if you triple the amount of value of r. So go ahead and pause and answer that question and then come back to us. So let's kind of walk through this. This is kind of like what Han did before. Let's go ahead and walk through this. We're going to have it as our volume. We have 7.33. Our r is going to be 3r squared instead of just r squared. So again, that's 7.33 times 3r times 3r, because it says take that and multiply it by itself twice. 3 times 3 is 9. R times r is r squared. So notice how it's going to be 9 times bigger than the 7.33. Let's take 7.33, let's multiply it by 9, kind of make our final equation. We're going to have it as v equals 65.94, and then r squared. So number 3, what we're doing is we are graphing the original situation that we're dealing with. And so our equation was v equals 7.33 r squared. So this is the equation that we want to go ahead and graph. Figure out your independent variable, your dependent variable. Go ahead and make a table for this, and then go ahead and graph the information. So as you can see, I went ahead and graphed this equation. I made a table. And so I put in different radiuses, and then I went ahead and graphed the information. So your graph should look like something like this. So as we were looking at this equation itself, and what we're actually going to go ahead and doing is if we go ahead and we triple the amount of our radius, so the radius, because it's being radius squared, it's not just going to double, and it's not just going to go ahead and half it just like before. Notice how the graph is actually kind of curvy. It's not the straight line like we did before, so it acts a little bit different than what the information what we were doing before itself. And this has to deal with the cone being like the 1/3 times pi times radius squared times height. So this is kind of what I was saying before, where this equation that we had before, notice how it was a straight line and it had to deal with a rectangular prism, or it had to deal with the cylinder itself. Here it had to deal with a cone, and the reason why it's curvy is because of the 1/3. Go back to page 195. Again, we're doing 2 lessons. So 195, the I can statements for lesson 17. Is I can explain in my own words by changing the height by a scale factor, changing the volume by the same scale factor, and I can create a graph, the relationship between volume and the height of all the cylinders or cones with a fixed radius. And this was actually the I can statements for both lesson 17 and 18. So give yourself a sentence on how you feel about today. Also give you your number. So 1, I'm still confused. 2, I kind of got it. 3, I did get it. And then 4, I can teach it to my friend. So remember, we are doing 2 lessons today. That means we have 2 practice problems. Practice problems for section 17, lesson 17, and also for lesson 18. So make sure you go ahead and get those done. Have a good day. Bye.